Question 264. The core business of your company is to rent out construction equipment at large scale. All the equipment that is being rented out has been equipped with multiple sensors that send event information every few seconds. These signals can vary from engine status, distance traveled, fuel level, and more. Customers are billed based on the consumption monitored by these sensors. You expect high throughput up to thousands of events per hour per device and need to retrieve consistent data based on the time of the event. Storing and retrieving individual signals should be atomic. What should you do? A. Create files in cloud storage as data comes in. B. Create a file in file store per device and append new data to that file. C. Ingest the data into Cloud SQL. Use multiple read replicas to match the throughput. D. Ingest the data into Bigtable. Create a row key based on the event timestamp. The correct answer is D. Ingest the data into Bigtable. Create a row key based on the event timestamp. Explanation. Google Cloud Bigtable is the most suitable choice for this scenario due to its design and capabilities. 1. High throughput and low latency. Bigtable is optimized for high throughput, low latency workloads, making it ideal for storing and retrieving time series data from thousands of devices. 2. Time series data. By designing a row key based on the event timestamp, example device_id, #reverse_timestamp, you can efficiently query data in time order and ensure atomicity for each event. 3. Scalability. Bigtable scales horizontally to handle massive amounts of data and high write rates, which fits the need for thousands of events per hour per device. 4. Atomic operations. Bigtable provides atomic row-level operations, ensuring data consistency during writes and reads. Why the other options are incorrect? Create files in cloud storage as data comes in. Cloud storage is designed for object storage, not for high-throughput event ingestion or atomic writes. Querying data based on time would require additional processing. Create a file in file store per device and append new data to that file. File store is a network-attached storage solution. It is not optimized for time series data or high-throughput scenarios. Managing file appends and ensuring atomicity would be complex and inefficient. Ingest the data into Cloud SQL. Use multiple read replicas to match the throughput. Cloud SQL is a relational database, and scaling it to handle high-throughput time series data would be expensive and less efficient compared to Bigtable. Replicas improve read performance but do not address write throughput challenges. Final recommendation. Use Bigtable with a well-designed row key, example combining device ID and a reverse timestamp, to efficiently handle time series data ingestion, retrieval, and scalability requirements.